Right now, something extraordinary is happening in the depths of our solar system. An ancient traveler from another star system, threei-atlas, has begun glowing an eerie green as it races toward Mars at over 40,000 miles per hour. This isn't just any space rock. This is our second confirmed interstellar visitor, and its sudden transformation has astronomers scrambling to understand what we're witnessing. You're about to discover why this green glow might reveal secrets about distant worlds, why the timing of its approach to Mars matters more than anyone initially realized, and what this mysterious visitor might be trying to tell us about the cosmos beyond our Sunday. The investigation begins. Right now, something extraordinary is happening in the depths of our solar system. An ancient traveler from another star system, threei-atlas, has begun glowing an eerie green as it races toward Mars at over 40,000 miles per hour. This isn't just any space rock. This is our second confirmed interstellar visitor, and its sudden transformation has astronomers scrambling to understand what we're witnessing. You're about to discover why this green glow might reveal secrets about distant worlds, why the timing of its approach to Mars matters more than anyone initially realized, and what this mysterious visitor might be trying to tell us about the cosmos beyond our Sunday. The investigation begins. Something changed about threei-atlas in the past few weeks, and astronomers around the world are struggling to explain it. What started as a relatively dim, unremarkable object moving through space has transformed into something that glows with an unmistakable green hue. This isn't the gentle green of Earth's aurora or the subtle tint of distant nebulae. This is a vibrant, almost electric green that seems to pulse and shift as telescopes track its movement. The green coloration in space objects typically indicates specific chemical processes. When we see green in comets, it usually means the presence of diatomic carbon molecules breaking apart under solar radiation. But threei-atlas showed no signs of this activity when it first entered our solar system. The transformation appeared almost overnight in astronomical terms, catching observation teams completely off guard. Dr. Sarah Chen from the Palomar Observatory was among the first to notice the change. "We've been tracking this object for months," she reported, "and suddenly our instruments started picking up spectral signatures we'd never seen before. The green wasn't gradual. It was like someone flipped a switch." What makes this even more puzzling is the intensity of the color. Most comets develop a faint greenish tint as they approach the sun, but threei-atlas is displaying a green luminosity that's visible even through moderate amateur telescopes. The brightness suggests an unusually high concentration of carbon-based compounds, far exceeding what we typically observe in solar system objects. But here's where the mystery deepens. Threei-atlas originated from outside our solar system, meaning it formed around a different star under completely different conditions. The elements and compounds that create this green glow shouldn't exist in the concentrations we're observing. The chemical fingerprint suggests processes that don't match our understanding of how interstellar objects should behave. The timing of this transformation raises even more questions. Why now? Why did threei-atlas wait until it reached this specific point in our solar system to begin its dramatic display? The answers might lie in what's about to happen next. October 3rd, 2025. Mark this date, because something unprecedented is about to occur. Threei-atlas will make its closest approach to Mars, passing within just 2 million miles of the red planet. In cosmic terms, this is practically a collision course, and the timing of the green transformation might not be coincidental. Mars sits in a unique position in our solar system's gravitational landscape. It's far enough from the sun to avoid the intense solar wind that strips away atmospheric components, yet close enough to experience significant gravitational influences. When threei-atlas passes Mars, it will encounter gravitational forces unlike anything it has experienced during its journey from interstellar space. But there's something else happening that most people don't realize. Mars is currently experiencing its own atmospheric phenomenon. The planet's thin atmosphere contains trace amounts of carbon dioxide that, under specific conditions, can interact with passing objects in unexpected ways. Recent data from the Mars Reconnaissance Orbiter shows unusual atmospheric disturbances that began appearing just weeks before threei-atlas started its green transformation. The mathematical probability of an interstellar object developing a green glow precisely as it approaches Mars is extraordinarily low. We're talking about odds in the millions to one. Yet, here we are, witnessing exactly this sequence of events unfolding in real time. Ground-based observatories have detected subtle changes in Mars's upper atmosphere that correlate with threei-atlas's approach. These changes suggest some form of interaction is already occurring, even at a distance of several million miles. The gravitational influence should be minimal at this range, which means we might be observing electromagnetic or chemical interactions that operate across vast distances. European Space Agency scientists have been monitoring both Mars and threei-atlas simultaneously, and their preliminary findings are remarkable. The spectral analysis shows that both objects are exhibiting similar wavelength emissions in the green spectrum. This suggests that whatever is causing threei-atlas to glow green is somehow connected to processes happening in Mars's atmosphere. The implications are staggering. If an interstellar visitor can influence planetary atmospheric conditions from millions of miles away, what does this tell us about the nature of space itself? The James Webb Space Telescope has been watching threei-atlas with unprecedented precision, and what it's revealing challenges our understanding of interstellar chemistry. The green glow isn't coming from the typical carbon compounds we expected. Instead, Webb's instruments are detecting molecular signatures that don't match anything in our existing databases. The spectral analysis reveals a complex mixture of carbon-based molecules, but arranged in configurations that shouldn't be stable under normal space conditions. These molecular structures appear to be held together by processes that operate differently than the chemistry we observe in our own solar system. It's as if threei-atlas is carrying samples of alien chemistry, created under the influence of a foreign star. Dr. Michael Torres from the Webb Space Telescope Science Institute describes the readings as unprecedented in 30 years of comet observation. The chemical signatures suggest temperatures and pressures during formation that don't match any known stellar environment in our local galactic neighborhood. This raises profound questions about where threei-atlas actually originated and what kind of star system could produce such unusual chemical combinations. But the most puzzling aspect is how these molecules are reacting to our sun's radiation. Normally, solar energy breaks down complex organic compounds, causing the familiar blue and green glows we see in traditional comets. Threei-atlas is doing the opposite. As it gets closer to the sun, its molecular structures appear to be becoming more complex, not less. Laboratory simulations have been unable to reproduce the chemical processes we're observing. When researchers attempt to recreate the molecular combinations detected by Webb, the compounds immediately break apart under any form of energy input. Yet threei-atlas maintains these impossible structures while being bombarded by increasingly intense solar radiation. The carbon-to-hydrogen ratio in threei-atlas is also completely wrong, according to current models of interstellar object formation. The ratios suggest formation in an environment with significantly different stellar output than our Sun, possibly around a red dwarf star with unique spectral characteristics. Recent analysis indicates that some of the detected molecules shouldn't exist at the temperatures measured in threei-atlas's coma. This suggests either our instruments are reading the data incorrectly, or this interstellar visitor is operating under physical laws we don't yet understand. When we compare threei-atlas to other space objects, the differences become even more striking. Our previous interstellar visitor, Oumuamua, behaved in ways that challenged our expectations, but threei-atlas is rewriting the rulebook entirely. Where Oumuamua was dark and cigar-shaped, threei-atlas is bright and actively transforming. Where Oumuamua accelerated mysteriously as it left our solar system, threei-atlas is slowing down in ways that defy conventional orbital mechanics. The size estimates for threei-atlas keep changing as astronomers gather more data. Initial calculations suggested a nucleus roughly 2 miles across, but the green glow is making accurate measurements nearly impossible. The luminosity suggests either a much larger object than originally thought, or surface materials that are extraordinarily reflective and chemically active. Traditional comets from our outer solar system follow predictable patterns. They develop comas and tails as solar radiation sublimates their icy surfaces, creating the familiar streaks of light we've observed for millennia. Threei-atlas is doing something completely different. Its tail isn't pointing away from the sun as expected. Instead, it seems to be following a curved path that suggests multiple forces are acting on the ejected material. The density calculations don't make sense either. Based on gravitational interactions with Mars's orbit, threei-atlas should be significantly more massive than its brightness suggests, or significantly less dense than any known space object. This creates a paradox that has planetary scientists reconsidering fundamental assumptions about interstellar matter. What's particularly unsettling is the way threei-atlas responds to solar wind. Most objects experience predictable pressure from the stream of charged particles flowing from our sundae. Threei-atlas appears to be channeling this energy rather than simply deflecting it, almost as if it's designed to harvest solar radiation and convert it into the green luminescence we're observing. Ground-based observations have also detected periodic fluctuations in the green glow that don't correspond to the object's rotation period. This suggests internal processes that are independent of simple solar heating. The fluctuations follow a pattern that repeats every 18 hours and 14 minutes, a period that doesn't match any known astronomical phenomenon. The trajectory data reveals another anomaly. Threei-atlas should have been influenced by Jupiter's gravity during its approach to the inner solar system, but its path shows no evidence of this interaction. It's as if the object possesses some form of propulsion or mass distribution that allows it to resist gravitational influences that should be unavoidable. The origin story of threei-atlas becomes more mysterious the deeper we investigate. Backtracking its trajectory through space reveals a journey that spans not just years, but potentially thousands of years through the interstellar medium. The path suggests it originated from the direction of the Vega system, approximately 25 light-years away. But the timeline doesn't match what we know about stellar mechanics and orbital dynamics. If threei-atlas truly came from the Vega system, it would have had to maintain its structural integrity through conditions that should have destroyed any normal space object. The interstellar medium contains radiation, cosmic dust, and electromagnetic fields that gradually break down even the most robust materials over extended periods. Yet threei-atlas appears to be in pristine condition, showing no signs of the erosion and chemical alteration we would expect from such a lengthy journey. The Vega system itself presents interesting possibilities. Vega is a relatively young star, approximately 450 million years old, with unusual characteristics that might explain some of what we're seeing. The star produces significantly more ultraviolet radiation than our Sun, which could have created the unique molecular structures now glowing green in threei-atlas's coma. But Vega's known planetary system doesn't include the type of large, rocky worlds typically associated with comet formation. Recent analysis of the object's internal structure using radio telescopes suggests a composition unlike anything in our solar system. The radar signatures indicate layers of different materials arranged in patterns that don't match natural accretion processes. This raises the possibility that threei-atlas isn't a natural comet at all, but rather some form of artificial construction designed to survive interstellar travel. The velocity data presents another puzzle. When threei-atlas entered our solar system, it was traveling at approximately 26 miles per second relative to our Sunday. This speed is consistent with objects from the local stellar neighborhood, but the trajectory adjustments we've observed since then suggest some form of course correction that shouldn't be possible for a natural object. Stellar motion models indicate that Vega and our solar system were much closer together, approximately 300,000 years ago. If threei-atlas began its journey during this period of closer proximity, it could explain some of the timing coincidences we're observing. But this scenario requires the object to have maintained a stable trajectory for 3 millennia while preserving chemically unstable compounds that should have degraded within decades. The chemical signatures detected by Webb also don't match the expected composition of materials formed in the Vega system's radiation environment. This suggests either threei-atlas originated somewhere else entirely, or it has been significantly altered during its interstellar journey by processes we don't yet understand. The James Webb Space Telescope's infrared capabilities are revealing details about threei-atlas that would have been impossible to detect just a few years ago. What Webb is showing us challenges not just our understanding of this particular object, but our fundamental assumptions about interstellar chemistry and physics. The most startling discovery involves the temperature distribution across threei-atlas's surface. Webb's thermal imaging shows that the object maintains different temperatures in different regions, with some areas significantly warmer than others, despite receiving identical solar radiation. This suggests internal heat sources, or thermal regulation mechanisms, that shouldn't exist in a natural space object. The infrared spectrum reveals water ice, but not in the crystalline form we observe in solar system comets. Instead, threei-atlas contains amorphous water ice structures that typically only form under extremely rapid cooling conditions. The presence of this ice type suggests formation processes involving sudden temperature changes that don't occur naturally in stellar environments. Webb has also detected organic molecules that are common in living systems but extraordinarily rare in space. These include complex carbon chains, nitrogen-bearing compounds, and phosphorus-containing molecules that on Earth would be associated with biological processes. While this doesn't prove the existence of life, it indicates chemical complexity that far exceeds what we observe in typical interstellar objects. The distribution of these organic compounds across threei-atlas's surface follows patterns that appear almost deliberate. Rather than the random distribution we would expect from natural processes, the molecules are concentrated in specific regions that correspond to the brightest areas of green luminescence. This suggests a direct connection between the organic chemistry and the visible transformation we're witnessing. Perhaps most remarkably, Webb's observations indicate that the chemical composition of threei-atlas is actively changing as it approaches the Sunday. New molecular signatures appear in the spectrum daily, as if solar radiation is triggering chemical reactions that create increasingly complex compounds rather than breaking them down. This reverses everything we thought we knew about how solar energy affects organic matter in space. The telescope's polarimetry measurements reveal another anomaly. Light reflected from threei-atlas shows polarization patterns that don't match any known material. This suggests surface structures organized at microscopic scales in ways that don't occur through natural geological processes. The polarization data indicates a surface texture that might be artificially maintained or self-organizing. Webb's temporal monitoring capabilities have also detected fluctuations in the infrared emissions that correlate with radio signals detected by ground-based observatories. These signals are extremely weak and follow no recognizable pattern, but their synchronization with thermal changes suggests some form of internal activity that responds to external stimuli. As threei-atlas continues its approach toward the Sun, something extraordinary is happening to its interaction with solar radiation. Rather than simply heating up and sublimating like a normal comet, This interstellar visitor appears to be harvesting solar energy and converting it into increasingly complex chemical processes. The green luminescence has intensified dramatically over the past month, but not in the gradual way we would expect from solar heating. Instead, the brightness changes follow a pattern that suggests the object is actively regulating how it responds to solar input. During periods of high solar wind activity, threei-atlas becomes brighter. During solar quiet periods, it maintains a steady glow that requires an internal energy source. Solar observatories have detected unusual magnetic field interactions between our Sun and threei-atlas that shouldn't be possible at the current distance. The object appears to be generating its own magnetic field that interacts with the solar magnetic field in ways that create localized distortions visible in satellite imagery. These magnetic interactions are focusing solar wind particles towards specific regions of threei-atlas's surface, creating hotspots that correspond exactly with the brightest areas of green glow. The solar wind particle analysis reveals another mystery. When charged particles from the Sun interact with threei-atlas, they don't simply bounce off or get absorbed. Instead, they seem to be captured and redirected in ways that suggest the object's surface is designed to channel solar energy. The redirected particles follow curved paths that spiral around threei-atlas before being ejected in controlled streams that contribute to its unusual tail formation. Recent observations have detected X-ray emissions from threei-atlas that only occur when certain types of solar radiation interact with the object's surface. These X-rays follow pulse patterns that repeat every 6 hours and 37 minutes, suggesting internal mechanisms that regulate energy absorption and release. The X-ray signatures don't match any known chemical process involving solar wind interaction with natural materials. The object's coma, the glowing envelope of gas and dust surrounding the nucleus, is behaving in ways that violate conventional physics. Instead of expanding uniformly as solar heating increases, the coma is contracting in some regions while expanding in others. This creates a complex, asymmetrical structure that changes shape in response to solar activity levels. Most puzzling of all, threei-atlas seems to be anticipating changes in solar output. The object's brightness and magnetic field strength begin changing hours before corresponding changes in solar wind intensity reach its location. This suggests either some form of faster-than-light communication with the Sun or predictive capabilities that shouldn't exist in inanimate matter. As threei-atlas closes in on its October 3rd rendezvous with Mars, the connections between the two objects are becoming impossible to ignore. What started as a curious coincidence is now looking like a coordinated interaction that spans millions of miles of space. Mars's atmospheric monitoring stations have detected unprecedented changes in the planet's upper atmosphere that began precisely when threei-atlas started its green transformation. The Martian ionosphere is showing disruptions that follow the same periodic patterns as threei-atlas's luminosity fluctuations. This synchronization suggests some form of electromagnetic communication between the interstellar visitor and the red planet. The Mars Reconnaissance Orbiter has photographed unusual cloud formations in the Martian atmosphere that appear to be oriented toward threei-atlas's approach path. These clouds contain higher than normal concentrations of carbon dioxide and water vapor, creating atmospheric conditions that haven't been observed since monitoring began. The cloud patterns shift and change in ways that mirror the brightness variations in threei-atlas's green glow. Ground-penetrating radar from the InSight lander has detected subtle seismic activity on Mars that correlates with threei-atlas's position in its orbit. These micro-earthquakes are too small to be caused by gravitational influence at the current distance, yet they follow the same 18-hour pattern as the interstellar object's luminosity cycles. This suggests forces operating beyond conventional gravitational mechanics. The European Space Agency's Mars Express orbiter has been monitoring both objects simultaneously and has detected radio emissions from Mars that weren't present before threei-atlas entered the inner solar system. These signals are extremely weak and don't follow any known pattern, but they occur at the same frequencies as radio emissions detected from threei-atlas itself. The synchronization suggests some form of resonance between the two objects that transcends normal electromagnetic interaction. Most remarkably, the chemical composition of Mars's thin atmosphere is showing trace changes that match the molecular signatures detected in threei-atlas's coma. These molecules shouldn't be able to travel the millions of miles between the objects, yet both are exhibiting the same unusual carbon-based compounds that glow green under specific conditions. This raises the possibility of some form of long-range chemical or quantum interaction that operates outside our current understanding of physics. The orbital mechanics of both objects have also shown subtle variations that suggest mutual gravitational influence, even though the masses and distances involved make such interaction mathematically impossible according to Newton's laws. The trajectory adjustments are minimal but measurable, indicating forces that operate more strongly than gravity at interplanetary distances. As the October 3rd flyby approaches, both Mars and threei-atlas are showing increasing levels of activity that suggest their interaction will intensify dramatically when they reach closest approach. The October 3rd flyby of Mars represents more than just a close encounter between an interstellar visitor and a planet. Based on the patterns we've observed, this event could provide unprecedented insights into the nature of threei-atlas and its purpose in our solar system. Computer simulations of the flyby predict that gravitational interactions will cause threei-atlas to adjust its trajectory slightly, potentially altering its approach to the Sunday. But the simulations also suggest something more intriguing. The close approach to Mars might trigger changes in the interstellar visitor that reveal its true nature. If threei-atlas is indeed some form of probe or artificial construct, the gravitational and electromagnetic environment around Mars could activate systems that have remained dormant during its long interstellar journey. The timing of the flyby also coincides with Mars's closest approach to Earth in its current orbital cycle, meaning our observational capabilities will be at their peak during this critical period. Ground-based telescopes, space-based observatories, and Mars orbital missions will all be positioned to monitor the interaction from multiple perspectives simultaneously. Perhaps most significantly, the flyby occurs just 26 days before threei-atlas reaches perihelion, its closest approach to the Sun on October 29th. This timing suggests that whatever happens during the Mars encounter could prime the interstellar visitor for even more dramatic transformations as it experiences maximum solar radiation intensity. The green glow that has captivated astronomers worldwide might be just the beginning of threei-atlas's revelations. If the object truly originated from another star system, and if its behavior suggests artificial construction or design, then its approach to our Sun could activate systems that have been waiting for exactly these conditions for thousands of years. The chemical signatures that don't match our understanding of natural space objects, the magnetic field interactions that shouldn't be possible, the synchronized behavior with Mars across millions of miles of space, all point to something far more significant than a simple interstellar comet. Threei-atlas might be carrying information, technology, or even life from another star system, and its green transformation could be its way of announcing its presence to any civilizations capable of understanding the message. The investigation continues, but one thing is certain: threei-atlas has already changed our understanding of what's possible in the cosmos. Whether it proves to be a natural phenomenon operating under physics we don't yet comprehend, or something more extraordinary, this green visitor from the stars has given us a glimpse into the vast mysteries that await discovery in the universe beyond our Sunday. The answers are coming. October 3rd will tell us if we're ready for them. As we stand at the threshold of these remarkable October events, threei-atlas has already delivered a message that transcends its mysterious green glow. This interstellar visitor has shown us that our universe contains phenomena that operate beyond our current scientific frameworks, whether those phenomena are natural processes we haven't discovered or something more extraordinary. The green transformation of threei-atlas represents more than just unusual chemistry or exotic physics. It demonstrates that objects from other star systems can carry complex information across the vast emptiness of interstellar space and remain coherent enough to interact meaningfully with planetary environments. The synchronized behavior with Mars, the impossible molecular signatures, the regulated energy interactions with our Sun, all suggest levels of organization and purpose that challenge our understanding of how matter and energy behave in space. If threei-atlas proves to be a natural object, then we must expand our theories about how stellar environments can create and preserve complex chemical systems across interstellar distances. The implications would revolutionize our understanding of organic chemistry in space and the potential for life to emerge in environments we previously considered hostile or impossible. If threei-atlas proves to be something more than natural, then we face questions that extend far beyond astronomy and physics. The green glow might be a beacon, a message, or a form of communication designed to be recognizable to civilizations capable of understanding its significance. The timing of its arrival, the synchronization with Mars, the approach during our era of advanced space-based observation might not be coincidental. Either possibility transforms our perspective on our place in the cosmos. We are no longer alone with our familiar solar system objects, following predictable orbits and obeying well-understood physical laws. The universe has revealed itself to be far stranger, far more complex, and far more connected than we ever imagined. The green visitor from the stars has already given us the most important gift any scientific discovery can provide: proof that there is still more to learn, more to discover, and more wonders awaiting our investigation. Whether threei-atlas represents advanced physics, interstellar biology, or something beyond our current ability to categorize, it has expanded the boundaries of what we know is possible. The investigation may have begun with a simple observation of an unusual green glow, but it has led us to questions that will occupy scientists for generations. Threei-atlas has reminded us that the universe is vast, ancient, and full of mysteries that reward careful observation with revolutionary insights. The green glow continues to brighten as October approaches, and with it, our anticipation of revelations that could change everything we thought we knew about the cosmos and our place within it.